Okay, let's get into this. Welcome to the deep dive. This is where we take a bunch of sources, articles, research notes, and boil them down to the key insights. Basically, we do the reading so you get the important stuff.
And today, well, we're tackling something straight out of fiction, really. The vampire.
Right, but asking maybe a slightly unsettling question, is there any scientific basis, even a sliver, for those legendary traits?
Exactly. We've been looking at medical info about a real condition, porphyria, places like Mayo Clinic explain it well, and also some biological takes on vampire myths.
Yeah, some really interesting angles.
So our mission, if you like, is to see if this idea of a scientific vampire holds any water at all based on actual biology and genetics.
It's a pretty cool way to get your head around some fascinating biology, maybe some slightly weird biology, through this classic myth lens.
Definitely.
Okay, so let's set the scene. We all know the standard vampire checklist from stories, right? Immortal, needs blood, hates the sun.
Fangs, hangs out in the dark, all that.
Yeah. So forget the drama for a sec. Could a virus, or like a weird mutation, maybe a super rare disease, could that explain any of it biologically?
That's the core question. We're moving away from folklore and asking, okay, in a lab setting, is there any biological mechanism, even a really out there one, that could result in these kinds of traits in a human-like creature?
Right. So trait number one, the big one, the thirst for blood.
Yeah, just surviving on blood.
For something our size, the sources we looked at really hammered home what a massive biological hurdle that is.
It's pretty stark when you break it down. Blood, okay, it's got loads of iron, which, kind of fits the whole pale victim idea. But it's surprisingly low in other essentials, like carbs, calcium, fats. Not much there. And it's mostly water.
Right, tons of water. So how do actual blood feeders do it, like vampire bats? Or mosquitoes?
Well, they've got these incredible super specific adaptations. Vampire bats, they have specialized teats for making little cuts, saliva that stops clotting.
Anticoagulants.
Exactly. And their kidneys are amazing. They can pee out most of that excess water almost instantly while they're still feeding even.
Wow. And mosquitoes are leeches?
They're tiny, right? So they need way less volume. Plus, specialized enzymes to digest what they get.
So for our hypothetical human-sized vampire, based only on these biological challenges, you'd need some, serious re-engineering.
Oh, totally radical changes. You'd need a metabolism that could somehow, pull enough energy out of that very specific, very unbalanced diet.
And deal with all the iron and water.
Yeah, the digestive system, the kidneys.
Yeah.
They'd have to be completely different. And the fangs, not just for looks, they need to be precision instruments for getting blood quickly and efficiently.
Okay, let's shift gears. This one feels almost creepier because it connects to real stuff. The aversion to sunlight.
Not just ouch bright light, but a serious, damaging biological reaction.
And this is where porphyria comes in, right? The sources brought this up.
Yeah, porphyria. It's actually a group of rare genetic disorders. And a key feature for some types is extreme photosensitivity.
Meaning sunlight is actually harmful.
Deeply harmful. There's one type, congenital erythropoietic porphyria, sometimes called Gunther's disease.
Okay.
Some sources link it speculatively to vampire folklore because it causes such intense reactions to sun. We're talking painful, blistering, even disfigurement on skin that's exposed.
Just from sunlight. That lines up disturbingly well with the myth.
It really does. And the material also mentioned that this type can sometimes cause severe anemia.
The blood link again?
Potentially,
Hey.
leading maybe theoretically to a craving for iron, which is in blood.
Yeah.
And it can also cause gums to recede, which might make teeth look more prominent.
Oh, whoa. Okay, so you've got the sun avoidance, a possible blood connection, and even something affecting the teeth. That's uncanny.
It is. You see these specific real symptoms, and they just echo parts of the legend. And there are other kinds of porphyria, too. Well, porphyria cutanea tarda is the most common. It also causes major skin issues from the sunburning, blisters, skin fragility.
Ouch.
And erythropoietic protoporphyria, another type, causes rapid, painful skin burning and swelling from light, leading to thick, scarred skin over time.
And the sources mention another condition, too, xeroderma pigmentosum, XP.
Right, XP, that's another genetic one. Extreme sensitivity again, but specifically to UV radiation.
So sunlight.
Exactly. It causes terrible sunburns, massively increases skin cancer risk. People with XP often have to live completely nocturnally, avoiding all sunlight.
So the idea of a life lived in darkness because light is physically dangerous that's real.
It's a harsh reality for some, and it gives a pretty solid biological basis for that core vampire weakness, doesn't it? You could imagine a hypothetical vampire biology where, I don't know, their blood chemistry or skin composition reacts violently to UV, causing cells to break down fast or triggering immense pain.
Okay, let's talk about maybe the most desirable trait, immortality, or at least not aging.
Yeah, the unaging aspect. True biological immortality is, well, extremely rare, almost non-existent in complex animals as we know them.
But the research we looked at mentions some ways organisms cheat aging, like telomeres.
Right, telomeres, those protective caps on the ends of our DNA, they tend to shorten each time a cell divides, which is linked to aging.
Like a countdown timer for the cell.
Pretty much. Eventually they get too short, cells stop dividing or they die. But some life forms seem to bypass this. The sources mention things like the hydra, or that immortal jellyfish.
Turritopsis dohrnii.
That's the one. Can actually revert back to an earlier polyp stage. It's wild.
And what about lobsters? Or naked mole rats? They live incredibly long lives, right?
Yeah, they show what's called negligible senescence. They don't seem to age in the typical way, likely due to really effective cellular repair mechanisms.
Okay, so how might a theoretical vampire achieve this, based on the science and the sources?
Well, the material floated a couple of ideas. One was a sort of vampire virus.
A virus?
Yeah, maybe one that inserts genes to constantly repair or lengthen those telomeres, stopping that cellular clock. Or perhaps a genetic mutation that just massively boosts cellular regeneration and DNA repair across the board.
Making them super resistant to damage and decay.
Exactly. Almost biologically immortal in that sense. Constantly repairing, not really aging.
But what about the literal undead stuff, like no heartbeat, not breathing, but still moving around?
Yeah. That's where, according to the sources, current science really struggles to offer a plausible biological explanation.
Too far-fetched.
Pretty much.
Yeah.
Animation without blood circulation to deliver oxygen and nutrients. Or without respiration. How does healing happen? How is body heat maintained? The sources suggest you quickly move beyond known biology into needing, like, completely hypothetical energy sources or something non-biological making it move.
Makes sense. Biology needs, well, biological processes to work.
Right.
Okay, so how does this condition spread in the stories? The bite, the infection.
Yeah, the bite transmission strongly suggests an infectious agent, doesn't it?
No, disease.
Exactly. And the material we reviewed hypothesized maybe a really complex retrovirus.
A retrovirus, like HIV. One that writes itself into your DNA.
Precisely. But this hypothetical vampire viruses would need to be unbelievably sophisticated. It'd have to rewrite the host's genetics to bring about all those traits the blood need, sun aversion, healing, maybe the long life.
While stopping the body from fighting it off.
Yeah, and suppressing the immune system so it doesn't reject these massive changes. It's a huge biological ask for a single virus.
Sounds like something out of science fiction itself.
It really does. The sources did mention an alternative idea, too. Maybe the first vampire wasn't infected, but was like a one-off genetic fluke.
Mutation.
A massive, spontaneous genetic change, a sort of hyper-evolution event in one person created the template, and then maybe that condition became transmissible somehow.
But even then, you still bump into those problems we just mentioned, right? Like, how do the tissues function without, say, a heartbeat?
Exactly. The sources pointed that out. Even with amazing regeneration, how does it work without circulation delivering the building blocks and energy? That remains a really big biological puzzle within the purely scientific framework we explored.
Fascinating stuff. So let's circle back to porphyria for a moment, based on the Mayo Clinic info. Give us a bit more detail on the real condition.
Okay, yeah. So porphyria isn't one single thing. It's a group of mostly inherited disorders.
Yeah.
And they result from a buildup of natural chemicals called porphyrins in your body.
Porphyrins. And those are normally used for something.
Yes, they're building blocks for heme. Heme is a part of hemoglobin, the protein in red blood cells that carries oxygen.
Got it.
Heme's also important for breaking down certain drugs and hormones. It's mostly made in the bone marrow and liver. Now, there are 8 enzymes involved in turning porphyrins into heme.
Like an assembly line.
Exactly. If you have a shortage of one of those enzymes, usually due to a gene change, the porphyrins can't get processed properly, they build up. And high levels cause problems, mainly affecting the nervous system or the skin. Hence the photosensitivity we talked about.
And it's usually inherited.
Mostly, yeah.
Yeah.
It can be autosomal dominant, you only need one changed gene from one parent. Or autosomal recessive, you need a changed gene from both parents. But Importantly, just inheriting the gene doesn't always mean you'll get symptoms.
Ah, okay, so it can be hidden.
Right. And there are also acquired forms, like porphyria cutanea tarda, PCT, the common one, that can be triggered by things like too much iron in the body, certain viral infections like HIV or Hep C, heavy drinking, smoking, even hormone changes.
So triggers can bring it on even if you have the genetic predisposition.
Yes, or even in acquired cases. Things that increase the body's demand for heme can overwhelm the faulty enzyme. So triggers include sunlight, certain medications like some birth control pills or sedatives, recreational drugs, dieting or fasting, smoking, physical stress like infections or surgery, emotional stress, alcohol, hormone shifts.
Wow, a lot of potential triggers. And what are the complications? You mentioned skin damage.
Yeah, for the cutaneous types, you can get permanent skin damage, infections in the blisters, changes in skin color or texture, slow healing, scarring. For the acute types, which affect the nervous system, attacks can actually be life-threatening if not treated fast.
Life-threatening.
Yeah, they can cause things like dehydration, breathing problems, seizures, high blood pressure. You might need hospitalization. And repeated attacks can lead to chronic pain, kidney failure, or even liver damage or cancer long-term.
Serious stuff. Is there treatment?
Treatment depends on the type, but it often involves managing symptoms and avoiding triggers. In rare, severe cases, a bone marrow or liver transplant might be considered.
So prevention is key if you know you have it.
Definitely. Avoiding triggers is crucial. And genetic testing and counseling for family members can be really important too. The key message from the medical sources is, if you have symptoms that could be porphyria, see a doctor. Prompt diagnosis and treatment make a big difference.
Okay, that really grounds the porphyria connection. Thanks. So bringing it all together, the science and the myth.
Yeah, synthesizing it. I mean, looking at these real biological concepts, these actual conditions, it definitely gives you a different perspective on the fictional vampire. Sometimes an unsettling one.
It shows just how weird and wonderful and sometimes scary biology can be.
Absolutely. The range of what's biologically possible or what can go wrong in specific ways, it's vast.
So the big takeaway for you listening, look, the classic Dracula, still myth, obviously.
Still fiction.
But when you dive deep like this, using these sources to look at the traits scientifically, you find this really fascinating overlap between biological possibilities and real conditions like porphyria or XP.
And you think about breakthroughs happening now in genetics, in longevity research. The lines of what we think is biologically possible are constantly shifting, aren't they?
They really are. So, the vampire, viewed through this lens from the sources, it's less supernatural horror, maybe, and more of a chilling biological what if.
Mm-hmm. It highlights how adaptable life can be and maybe how fine the line is sometimes between normal biology and something else.
What really struck me was how specific symptoms of real conditions, like the porphyria details, echo the folklore.
Yeah, those parallels are quite startling when you lay them out.
Maybe the most compelling horror, then, isn't the fanged monster, but that little flicker of recognition, that thought that somewhere, somehow, a tiny piece of that monstrous biology might actually be plausible.
It's a provocative thought.
So think about everything we covered from these sources, the blood challenges, the light sensitivity, the potential for extreme longevity, the idea of transmission. What specific trait, for you, feels the most scientifically plausible? Or maybe just the most unsettlingly real? Something to chew on.